Hello, everyone, and welcome to today's SolidWorks Deep Dive Live Design session. I'm thrilled to be here with you all as we explore some of the most powerful tools in SolidWorks. So, these tools are configurations, equations, dimensions, global variables, configuration publisher, and many more. Think of this session as pulling back the curtain on how you make your models smarter, faster, and more flexible. Whether you are chasing efficiency, dealing with frequent design changes, well, I'm not alone. Joining me is the great Mike Sandy. Mike has been helping engineering and design companies across North America and globe for more than a decade, with deep expertise on SolidWorks, simulation, general CAD and CA tools, and data management. He's not a problem solver. He's not only a problem solver, but also someone who brings both technical mastery and creativity into his design. So, outside of engineering, he is passionate about photography, digital art, skiing, and biking. But today, he's here with us to share his wisdom on CAD. So, Mike, it's great to have you here.
Hey,
So,
Capri.
I'll hand over the session to you. Yeah.
Thanks, man. Yeah, I think it's a fun topic. I'm excited about it. When I volunteered to do this one, it aligns with kind of the rollout for 2026, and we'll talk
Yeah.
more about that at the end of the show.
Yeah.
But I had to put something together that I hopefully will be great for the audience here. So we're going to get into configurations, global variables, as you mentioned. We'll do some equation stuff. Have fun with the software. Show some hopefully tips and tricks. But I lucked out because I had done this presentation back in 2017 at a user group presentation. So I went back, rehashed that, and when I was watching it, it rolled back a bunch of features in SolidWorks that I kind of had forgotten about, and I'm hoping I can share the excitement with the audience today. But I got a lot to cover, so we'll dive in. And Gurpreet, thanks for the great introduction. But right to yourself, a master of the trade of data management, governance, CAD, composer. I mean, you're a well-versed guy too. So as we go through, I know you're the host, but you're a bit of an expert. So feel free to chime in.
Sure.
Eric, thanks for seeing you. Jen, I see you in the chat as well, and Aquamaker and everyone else that's in there. Feel free to say hi, and if you have questions along the way, let me know. I can try to answer them. But with that, let's dive in and talk a little bit about just some cool stuff in SolidWorks, right?
Yeah.
Now, one of the first topics I wanted to show is like getting into basic sketching, right? We're all familiar with starting a new 3D part. You need to start with a 2D part or 2D drawing of some sort. When you're doing this, I don't know if you've ever noticed, but when you create a sketch, these sketches in the back end of the software, they get named. And this is how everything is kind of organized. And if you've ever paid attention to it, it's pretty simple, right? The first sketch you draw is going to be sketch 1. If you delete that sketch, you draw another one, sketch 2, and so on. If you are hacking through a part and later on you might see you have sketch 53, that's how many times you've created a sketch inside of there. And this is what the software does to kind of keep things organized. So if we look at the tree, we see we have that sketch 1. Go through. If I go ahead and exit out of this sketch, we'll come in, just create another sketch to it. Could be within the same. It's going to give me a sketch 2, right? Exit out. We can see sketch 2 exists. So those are important to understand kind of what's going on, because as you add dimensions, and we'll just go back to this initial sketch, I'm going to use my mouse gestures, my preferred way, and we'll give this a value, maybe 100 millimeters, doesn't really matter for the sake of this. And if I click on that, double click on it, you're going to see that this now has the name D1 at sketch 1. All right. So the first dimension added to my first sketch. It's a really simple nomenclature to get once you see it. You probably, a lot of the folks in this chat, I know already know this. But if you're watching this and maybe that's new to you, be aware that that's happening, because as we go into equations and as you get into configurations, you'll start to understand what those little nomenclatures mean. D1 at sketch 1, D2 at sketch 2, D3 at pattern 1 are very important for being able to to address those. Now, as you go through and you start to create these sketches, be aware you can do a few things. For instance, in a circle, if we wanted to give this a name, we can override that and say, instead of D1, let's call it radius, right? Or sorry, this is going to be diameter. So give that a new name. And if we come back, double click here, you can now see DIAM at sketch 1. This is all goes into how you approach a model, design intent with a model. If we want to have something that's driving it, it's worthwhile to spend the time to give some naming convention to your sketches, because if you're going to go and start configuring these, do design tables, having that more intuitive name versus D1, D2, D3, and try to remember what those are at, you can do that just by adding it on the fly. Now, another area, and if I wanted to go through, we'll just do another sketch here, is you're probably familiar with, is being able to tie these dimensions together. So in this case, I'm going to add a dimension. If we can think of this, sketch 2, right? On this one, and we have, sorry, this is still sketch 1, but we have a dimension 2. This is the second dimension I've added into this first sketch. Double click on it, we see D1 at sketch 1. It's been now created because I renamed the first one, and we can give this a variable name, like we'll just give this height. All right, so then those are named, right? Simple enough. Now we have two sketches existing within this one sketch feature. They've got two names to it. We can understand that. But what if we wanted to create some sort of relation to those two? Now, when I first started in SolidWorks, simple enough, I just realized that, hey, we all probably know you can do an equals, and then you can select on another dimension. And you'll see that this is equals to diameter at sketch 1. Click the OK. That was cool, right? Like, wow, now I've got this relationship here where if we change my diameter to 150, that's going to drive that other dimension. But if I come back here, I can't put in that 150 here because this height dimension is driven by the diameter dimension. There's actually an easier way to do simple variables, and this is just by linking them. So what I'm going to do is just recreate this dimension here. I could have killed the global variable, but I'll right click on it, and we're going to say link value. All right. You're going to get this little shared value screen come up, and you can give it any name. So think of these linked values as a master variable that can connect many values all the way out. And we'll just call this like master dimension. All right, we'll add that in there, click the OK. And I can come back to this initial one, right click on here, say link values. And we're gonna go ahead and we'll see in the list that master dimension is now available. All right, so what you'll see is you get a little link symbol, chain link. It kind of looks like the infinity symbol, but that's just basically indicating that we have a very simple link between these two, and it's bidirectional, and that's key. So if we wanted to go through and say 120 millimeters on this dimension here, we're going to update that diameter. We'll go back to maybe 200 millimeters here. Go ahead and update, and we're going to see that's going to update the other dimension. So a nice way if you're going to go through and you know, for instance, that you have one variable, one dimension that's going to be driving many, but you don't want to have to figure out exactly which one was that. So not using equations, you can simply link these and be able to yeah, as Deepak was saying, they're super underrated.
Yeah.
And I think for me, it was like, because I'd always do equations, but then it's always remembering what's the master, everyone is equated to the initial.
Yeah, I think, Mike, these are the very fundamental basic blocks of the design intent that we try to capture, and this basically feeds the complex automations that we can do further in our design. Yeah. So as Deepak mentioned, yeah, this is something which is underrated, but yes, I can imagine that how a budding designer, a new designer, is going to get a lot of value out of it moving forward.
Yeah. So once you kind of get this, then it kind of grows into being able to understand where equations become. And this isn't, again, none of this is super difficult stuff to grasp at all, but it is foundational to be able to create very intelligent models. And we'll look at an example here in a little bit. All right, so let's go ahead and add another dimension here. And we're going to say link value. So I'm going to go ahead and create a new dimension. We'll just give that 160. But in this case, we want to have this as a little different. Instead of a linked variable, we're going to create this as a global variable. Global variables are very powerful, and we'll see an example of how global variables can drive an entire model. They can be used in assemblies, they can be used in parts, and they basically allow you to go through a name a little bit different. We're not naming, but we're naming a variable that will drive that dimension. So let's take a look and just call this simple enough width. All right. You'll see the symbol once I've approved that. I can toggle and see what the name is. Maybe you're trying to go back and write an equation later on. Simply toggling that on and off will tell you what that variable is. To kill it, you just highlight, delete it. In this case, we're going to keep it as that width. And now we have 160, and you'll see the little sigma symbol above that, right, or to the left of it. So 2 symbols to be aware of. We have linked, very simple, right? Linked dimensions just mean there's a name and it drives all of them. Change one, updates the other. Change a different one, updates them all. And if we come back and we look at this, we can then go your equations folder on the left side. And I think my Zoom it's working. It wasn't working yesterday. Oh, perfect. So if we have, well, let's try again. Yeah, it's not working. Something with my monitor. Sorry about that. But you'll see the equations folder becomes visible. And let's go ahead and manage this equation. And we'll kind of introduce this a little bit. All right. So the equation manager, this is going to be a nice place that tracks not only your global variables, your equations, but also just dimensions you can look at as well. Oftentimes, if you have like a master sketch has a lot of things going on, you have a lot of equations, and you're trying to troubleshoot, it's a good place to look at it. If you're new to this, a couple, I don't know, 5-6 years ago, maybe longer now, this came out, this automatic solver. The order in which you put equations in used to matter. Now this doesn't. So I always enable this. Basically, if you had a variable below an equation, it wouldn't solve correctly. So you need that. And another one is the automatic rebuild. We'll look at this, how this works a little bit. But this basically says if you make a change here, rebuild the model for me. Don't make me force that rebuild. Okay, so let's see what we have. We have width equals 160. That's that global variable I just created. And then we have master dimension. So that linked variable is shown here, but it's grayed out. I can't change it from this dialog. I can only change it by going back to that sketch. But what I can do is I can just say, let's say this width, I don't want it to be equal to 160. I can go and see that linked variable is still there. I want it to be the master dimension. And let's just do that divided by, I don't know, 3, okay? And just like that, this width variable, we exit out, and we'll see our sketch. Go ahead and edit that. That's been updated. So now this width is driven either by a change over on this diameter, 150. We're going to see that's going to update everything across the board. So you can get pretty involved into these. And again, I'll check an example here in a little bit. But that's a lot of the basics of those 2 fundamental things, along with just like general cleanup, naming dimensions. If you're going to have elaborate master sketches, I do it all the time, especially when you get into configuring those, creating linked variables along with global dimensions and how they can all intertwine. And you can start to drive some pretty good intelligence there.
Yeah, Mike, I believe we have gone pretty far in how we were dealing in equations around 10 years back, 15 years back. And with the introduction of this automatic, you can say, solve check, and now we need not to rely in which is way we were creating our equation. So I believe it's much more easier and handy for users to adapt.
It totally is, yeah.
Yeah. So, Mike, sometimes I feel it is a little overwhelming too when we talk about equations. So, do you have any tips for budding engineers or someone who is starting new with SolidWorks on how to manage the equations and how to get around with it?
Yeah, I think simple enough is start with something very, very basic. Any application engineer, anyone new to SolidWorks that's maybe or someone's using it, showing someone else SolidWorks, what do we usually make? Plate with a hole, right? Yeah. So you start with a simple plate, simple rectangle, give two global dimensions, build that equation to say, hey, if the width changes, change the height, add a hole. And then you can say, hey, let's have this hole driven by, again, an equation. Or this is exactly where I kind of built this little model. This thing is the farthest thing you would ever want to see in a production CAD model. So please don't reference it. But I think it was really fun for me to create. I actually started kind of was like, I need a good example for this. So what I did is I came through and I have 3 bosses that are just driven off of a multi-contour sketch. Okay. These you'll see, again, we have just a bunch of linked variables. So I don't even know what they're linked to. Double click on it. You'll see that link to it. We can select that to see the name. So box width. Here's another one. I think like tab height, whatever. I gave them a bunch of tab length and so on. Again, if you want to see the relations inside of them, we can open up the equations and we're going to see all of my linked variables. And then here I have a couple equations, right, that are using these different tabs and doing multipliers and doing a scaling factor to change those. And then I went through, I've got this shell in here that I tried to use. It didn't work out. Then I went through and I also created some sketches, and this is pretty sweet. So these actually are linked as well. So if we combine these two, and I'm just going to do this in Instant 2D, you can see that I now have kind of these little, again, this is not but I have drivers, right? I have little just lines that are driving the dimension of my model. And they go not only in the 2D sketch side of things, but you can see that I'm also using them in the 3D side. So things like an offset from a surface. Notice I'm pointing out this one right here. Drag this out. This is actually driving the boss extrude, not only the size of the shape of the 2D sketch, but also the depth of the boss extrude into 3D. So this, to answer your question, Gurpreet, it's a really good way to just learn how these intertwine and have fun and see where you can use them. Here equals tab to width, right? I'm using that driven that variable to be able to drive the actual depth of a and I think you can use equations in most places. I know it's not everywhere, but yeah, and run it. And there's Eric, you guys are bringing up a good thing. There are tutorials that are built right into SolidWorks that cover this. For me, it's always about just trying to break it and figuring out what the limits are, and having fun with it. And you can kind of discover a lot of, what can be done.
Yeah.
So let's look at an example. Yeah. Go ahead.
Yeah, I also agree with Eric and Ronit that yes, there are some fantastic tutorials available within SolidWorks, and I would vouch for the training content that we have, our training manuals. I think they are a great asset, especially for learning equations, global variables, and I can say configuration. So, yeah, so a lot of learning content is available. Yeah.
Using my recent key, I've got some examples that I've pinned down here. This is one that I don't know. I do a lot of work around the house, a lot of home projects, and I put this together pretty quickly on Monday. Sat down and thought, what are some things that have a serious set of rules? And designing a stringer for a house, these have requirements. You got to have a certain tread depth. You have to have a certain tread height. And that pretty much is going to design your stairs for you. There's how they go to the landing is affected with the dimensions. This, for me, I went online. I found, I don't have to write the math myself. I found the equations that are available online, and I use that to help me drive an intelligent design. So again, if you're looking to learn how to kind of go through this process, find a real world example and try to replicate it and build an intelligent model. One of the first ones I remember doing was a ladder where,
where
you just, when you stretch the length of the ladder and the rungs would update. There's an enhancement now that lets you we'll look at that in the linear pattern. It kind of lets you bypass the math, but doing it the old school way, saying, hey, if this drives up.
Yeah, so I remember doing the similar tutorial long back when I was learning SolidWorks. Yeah.
Oh yeah, Eric, you caught me. I am in PR1. Like I said, we just finished up with 2026. 2026 is a great release, and we'll be highlighting some of the new enhancements in 26. Everything I'm doing though in here goes way back. Like nothing is 2026. So if you're not on it, don't worry. All right. So what I did is I came through and I set up just a basic stringer, and let's look and see if we can recognize what we have. So there's some equations that are driving the position of this. Some of these are going to be my input equations, my input values. So the rise, which is the height to my landing, the run, which is the length of the stairs, 120 by 100. We also have this here gives me the cutoff on the top of the stair. And this here is actually the tread depth, right? So how big the stair is without anything on it. So I'm using those that are going to drive the position. And if we actually come back and just play with this, you're going to see, and there's some basic other elements as well. But update any of the dimensions here. Great, that looks good. We have relations that are driving this. Things like we always want to make sure this is a horizontal line. We always want to make sure this is a vertical. I do have an existing sketch, and let's take a look at it while we're here. I have an existing sketch inside of here that extends out where the landing is, because we have the location of the stringer where you would mount it to the stairs. And that is it's actually this 8.5. So this 8.5 drives the landing because it has to be down because your last step is up onto here.
Yeah.
11.5 is my bot stringer, my raw lumber. So I have that as well. You know, if you're doing a 2x, that'd be a 2x12, if you're doing a 2x10, which I don't think is by code, I could change that. But yeah, so there's some basic dimensions that aren't variable driven. And then here's 150, 89. This is just a driven dimension. That's why it's gray. And that driven dimension is actually giving me, not quite the stock, but I wanted to get the bounding box. And I could get that from the bounding box option in SolidWorks. Okay, so that was the first thing, is just give me some equations that are driving the rise and run of the stairs, and let the relationships figure out some of the main cuts. So let's go in those equations and look at it.
I believe this the sketch that you have done and the type of design intent you have captured, I think this is the key to capture your design intent at a very early stage in the design, so that you will be able to achieve a true parametric nature, and you can get the full potential of the parametric capability.
Yeah, 100%. One thing I will share with this, so I've been using SolidWorks. I mean, I started a long time ago, but like really using it was on a daily basis was 2011, 2012 timeframe. It was like my third go on making this. So if you're new to it and you're trying to do exactly what you're saying, is build a true parametric intelligent model, and you get halfway through and on this first part, like just the basic stringer, and it's not working, you're getting equation errors. Instead of just, I don't know how many times I just blew all the equations out and started fresh, or just a new part altogether, threw it away. Okay, what do I need to organize a little bit different in my mind, because you're learning things along the way.
Yeah.
And this is true for, like, I think we all know on here, right? Your first attempt at something is never going to be as good as that second one. And the third one, fourth one might get better, but between your first attempt that has a little bit more complexity into in a design intent, establishing a second fresh start, to me, is always way more efficient than trying to back my way to the beginning and the same model. That makes sense.
Yeah.
So,
makes sense. Yeah.
So yeah, like here's a great example. I couldn't figure out why my steps or my rise were going outside of code. And that's because depending on my input values, total rise, total run, so I can go measure at a house, we know how high it has to be, and let's figure out as long as it can be or fit in those parameters. Those are my two driving variables. The other I could switch that and say how many steps we want. So if you look in here, we have my count rise calculator and count run calculator. These are based on, again, these are construction standards. Okay. You can't go above 7 3/4 inch. So I just said, hey, let's shoot a goal of 7.5 inch rise of a step. Have you ever been steps that are like super high? No, they're all within a normal, height that we can walk up. Total run of the step, that's based on 2 2x6s or 1 2x12. that's going to sit on as the actual stair tread itself on top. So I said, let's make sure, what is 10 inches? And over here, this is telling me 13.33. This is going to be the count of steps if we are saying abide by that, or 12. So I'm going to either have 12 stairs or 13 stairs. That's all that's saying. Then I use step rise, and you can go a little bit beyond and use things like if then functions, saying, hey, if it is greater than 7.5, let's take away a stair. That's too high. Let's add a stair, sorry, because then we need to drop that height. And this right here is going to give me my step rise. So there's a few variables in here that I can switch along with like the step count approximation. And if you're lost in this, totally fine. I was too, until you do it, right? I went through and did the process. I'm like, oh, this makes sense. Yeah. So those are these equations that are driving it. Once I got everything working,
I believe it's so cool. We have just started with few basic things of linking and setting up the global variable. Now we have reached a stage where we are using if then else statements.
Yeah, sorry, we're kind of jumping ahead. And that, it's easy to do. It's just like, hey, if this, then that, else. I mean, you can get more involved, but start with just the equations if you're new to this.
Yeah.
So that gave me the simple enough. Like that was the next big piece I needed on it, was literally just the 10-inch, which is driven. This is my step, my step tread. The height doesn't matter because I want that to be the driving dimension. I just want to make sure that doesn't go too high. Yeah. And we'll look to see what happens. And then I have a driven dimension, which is going to be used in my pattern. Okay, so we have my cutout of the stringer. We pattern that up. Gut check. Yeah. Does it look right? We have all even values. This value here at 10 inches, 10 inches, 10 inches. Perfect. That's the hard part of cutting a stringer, is making sure all your steps are equal. And then I go ahead, pattern those out, 36-inch stringers. By code, we have to have 3. I created a little center plane. Here's a little tip. If you ever wanted to create a plane between objects, you can just click one face, click the other face. Nope, not that one. And then you're going to automatically center in there, and that's going to be a parametric feature or parametric reference. So if those update, I always stay centered. So I added that nice plane. And then just set in my stringers. These are 2x12s. Okay. My little backing, and then pattern that up. So that all worked, and I was so happy with it until I went to change a dimension and it blew up. And that's where you have to test it and then figure out what might be going wrong. But here, if we wanted to go, maybe our height is, 86 inches. We'll go ahead and just put in the input value, make the click, and just like that, we have an accurate set of stairs. Yeah. And I started, just trying to break this. Well, let's go to 144, make this a really long flat stair. And this is where you can see that maybe the stair tread is too much. Too long there. Okay. No big deal. That's why this is when I realized after playing with it that my step count, which is 12, and this is saying 11 to 14. 11 to 14. Well, if we add in, let's just average that and do a 13. Add a new stair to it. Click the OK, and that looks good.
Yeah, this looks good.
Yeah, so I've got a really smart model. If I wanted to, I could come back, delete all. This could be a master model where I just file save as new part number that goes to a drawing, up to go, and I can always just start with this initial one, put in my parameters, and let it run. So maybe as a little more of an advanced example, but with a little trial and error and using a preset, known, well-established set of equations that are easily found on the web, I was able to build this, then get a really good understanding of the behavior of my model by trying to break it. Going back, that's when I started to do the if-then functions and figure out that, hey, give me an estimate on how many stairs I'll need, and I could evolve this even more. I could make it completely intelligent, so the if-thens would build it in appropriately. So yeah, really fun stringer example, and that's kind of what I had for the equations, global variables. And again, in the chat, if you guys are using equations, if you linked variables, global variables, please let us know, share how or why. If you have questions as we go through, let me know.
Yeah. Mike, I believe this is the basic foundation, and then we can start building up on this, and we can manage probably large models and large assemblies too through this skeleton approach, and then capturing all the design intent.
What's interesting, I think, about this is we're not adding anything above the model. This is how
Exactly.
the
Yeah.
model behaves,
Yeah.
right? We're just doing a different input method to do exactly what we would manually. So it's not over complicating your models. It's simplifying it. So yeah, Gurpreet, you've got a lot of expertise in the CPQ space. We've got a great partner out there, DriveWorks.
Yeah.
This is what they do, right? They build
Exactly.
intelligent
Exactly.
models to streamline your automation.
Yeah.
All right, let's have a little fun. And I wanted to talk a little bit about some equations in SolidWorks and how we can use equations to drive actual sketches. The one that comes to mind, and there are a good amount of YouTube videos that are available on this, and I am not an aerospace engineer, so please do not try to fly a plane designed by my guidance here. But there are a lot of prototype pilots out there. There's a whole FAA regulation where you can kind of do whatever you want to build your own airplane and go fly it and be certified to do so. It's a cool space. So I wanted to talk a little bit about airfoils. And if you're not familiar with this tool, it's airfoiltools.com. This is a place where you can generate out known airfoil wings. They have anywhere from like Boeing 777s on here. They're huge. I was looking at one. They just look like big hot dogs to me. Like I'm like, this thing can fly. Where you get into some basic ones like the NACA 0018. This is what I use. These are really standard 4-digit airfoil codes, but you can basically come in here and generate out. You can send to a plotter and generate out your XYZ coordinates. Once you have those, so again, take a look at. There's a lot more here that I can't explain because I'm not an aerospace guy, but obviously the required lift you need, the size of the airplane. If you're going to be building like a 3D printed wing, these airfoils are used outside of aerospace, out of flying. They're also used in like wind turbine blades. So renewable energy type propulsion. Airfoils are also in water, right? Hydrofoils, all sorts of different applications. This will give you the CSV file, which we can go ahead and download and save out. Now, one thing I ran into and I wanted to make you aware of, and again, you can look this up. There's plenty of explainer videos on YouTube that go through this process. But when we're bringing these into SolidWorks, you got to do a little cleanup. You want to have all of these just set to, I'm so used to different Google Sheets. So bear with me, shift my cells up. Okay, so you need to have all this data cleaned up. This is the camber line, the center line, and the chord line. You don't need those. You also need a Z column. Okay, so SolidWorks is going to not like it unless you have X, Y, and Z determined, and Z for a 2D is going to be 0. The other thing you'll need is a UTF-8 text file. So what I'm going to do is save this out. I will just put this on my desktop. I'm going to do it as a Unicode text. This is, I don't know what version. I think this is 2024 Office. I just saw Eric's comment. Yeah, but I play one on YouTube. Yeah, that's my. So I'm going to save this text file out. This text file out of Windows 2024. I got to find it now. Hold on, guys. Or sorry, Office 2024. When I export it from, let's do, I'm on my other screen. I'll bring it up in a sec. Edit Notepad. Okay. So here's what I generated out. You got to do one more step. You got to file, save as, and I think older F, but you want to do this encoding to a UTF-8. If it won't read it, this is probably why. And then you'll have this text file, which we can then import to SolidWorks. So let's take a look. I'm going to create a new part. We'll work in IPS this time. And then I want to create a sketch. I don't need to create a new sketch because we're going to drive this directly from those data points. So under your curves, you have curve through X, Y, Z points. Remember, you can do X, Y, and Z if you want to create, and we'll get into that here with some equations. And then just browse over to that file. You'll change the file type. And again, this is my NACA 18 UTF-8 translation, and that comes in. Let's go ahead and take a look. And there we have almost a complete airfoil. It's not perfect, but that's all right. This is what we're going to work with.
Yeah.
Now, this is a generated curve, meaning we can't actually create any sketch geometry from it. We got to convert it one more time to something that sketches. Gurpreet, how would you do that? Yeah. I'm going to quiz you.
Probably I would like to go for a convert entity by maybe putting a plane.
What was the crowd here, the audience? What would you guys do to convert this curve to a sketch? Let's see if we get responses as we go through. Now, you can do it a couple ways. My instinct was same thing, right? I'm going to come in and create a sketch on that same plane because we used X and Y coordinates. We're on the front plane, which is on X and Y. I'm going to create a sketch. And we can select it, and we can simply do a convert entities, and that's going to give us that conversion. You'll notice that it's a little funky at first, but we can actually start to drag these endpoints out if we wanted to complete this. That's one way to do it. That's actually the way I'm going to do it. The other way you could do it is simply coming in and creating style splines if you want to have a fully defined version of that. And you're basically just going to trace this out, right? Again, don't try to build it and fly it, but you'll be able to get pretty much spot on to the curve. And style splines are a great way to derive splines because you can fully define these. So we can line that up and get a style spline. And again, if we want to come through, right click, I'll just cheat, say fully define, adds my dimensions in here. And now I have fully defined top spline. We'll exit out because I'm going to go and do the third way. The third way you could do this is by insert. And if you've ever worked, tools, spline tools.
Spline tools.
Yeah,
and
fit spline.
Fit spline.
This is a great tool, right?
Yeah.
Fit spline and select on that. It's going to give me a closed spline option. Sure. R.04 just means how exact it is. I don't know if you just saw that. I don't know if I can get it back. Let's try it. Yeah, it doesn't let me go back. But that R value just tells you precision. I think we learned that in statistics. And then we have another version of it. So 3 ways you could go about it, all work. And depending on how much you want to be able to modify your airfoil. To me, if I was designing a plane, I probably wouldn't modify the airfoil that I knew nothing about. But if you're going into flow, like if you're going to do some CFD, as Omar, my colleague Omar was mentioning, you might want to have some more to do it. So let's just go back, and I'm going to use your way. Gurpreet, we'll do our front plane. Let's convert the entities onto that plane. There we go. And then since we'll be adding in some sort of flaps to it, some ailerons and whatnot, I'm going to leave some back end open. Again, close contour. Looks good.
Perfect. Yeah.
And then I'm going to add in a center line as well, just to help establish where we're at. Give this a length if needed. It's a pretty big wing, 90 inches. I don't know what that might be, right units. Okay, so that's the first part. Now I could go through back to that plotter, and I can replot, and it'll give me the dimension along the wing for each one. Or what I'm going to do is just come in and add new planes. Not that. We want to do a new feature, and we'll do a reference geometry plane. We want to do that based on that front plane for 60 inches, sure. And then these are going to be the planes that drive where my rib locations are. Okay. Gotcha. So again, we could create sketches on each one of those to drive it. Or what I'm going to do is come into plane 8, and we'll grab sketch 3. I'm just going to copy and paste it. Just like that. We'll place that here, and we can dimension this out. I'm just going to kind of wing it where we think that belongs. But obviously, airplane wings taper. If you go look at pictures, go look outside, you'll see an airplane fly by. So we have to taper this down. Super easy way to do this is just to scale. So we'll scale my entities. Okay, about the front. We're at half. Sure, that works. Click the OK. Now we have the same profile, perfectly scaled. Now let's come back and we're going to go ahead and create a loft. All
Loft.
right, Gurpreet, how would you loft it? Surfaces or solids?
Uh, I would go with the solid loft
Solid
because I
loft. All
love
right.
solid modeling. Yeah.
Yeah, okay. I'm a surfacing guy, so my instinct is always, can I surface it first? Which is probably the way
Yeah.
wrong way to approach things. But yeah, I let's do solid.
Yeah.
Let's take a look at the solid. So we're gonna do a lofted boss. We'll grab this wing. We'll grab this wing, and that looks pretty dang good. Click the OK, and we have our lofted wing.
Yeah.
All right. But we got to be able to make this thing manufacturable. It's got to fly. So here's a cool trick to actually build out the ribs inside of it, right? To structure it. You have two main parts, the ribs, and then there's the oh shoot, I can't think of it. Anyone know the spar? The spar is the that goes through the wing. It goes the length of the wing, and the ribs are going to be along the wing. The Boeing wing I tried to do. These three, the next step didn't work. That's why I went to I'll show you a cool trick here. All right, so what I want to do now is create a new sketch, and I'm going to do a convert entities. And under convert entities, you have this intersection curve. This is such a cool tool. And what this does is says, hey, anywhere we have like planes or other surface bodies or solid bodies that are intersecting, I want you, let's go ahead and do this. Let's go back to create an intersection curve, and just like that we can produce out all of the geometry for our ribs. And then from there, extrude boss, I'm going to go ahead and grab every one of these. And so what happened is when I was trying to do this for oh yeah, I should point out this is actually a 3D sketch. So you can still extrude from a 3D sketch, but you need to give it a direction. And I'm going to do it normal to one of these planes. And now I can grab these contours. So just be aware if you're using that intersection curve, it generates a 3D sketch. You needed to give it a direction. And let's do that mid plane. Let's not merge, and we'll give that maybe like a 3-inch. Again, we'll click the OK. We'll tab hide that body out, and just like that, we've got all of those bodies that have been created. Now, the other way I had looked at doing this was coming back, and this is when I could not get the 3D sketch to work to extrude those. I think it was a zero thickness error. It wasn't giving me that, so I kind of gave up, find my workaround. The other way you could do it is just by creating a series of sketches.
Yeah.
And what I'm going to do here is let's just do a linear sketch pattern at we want this at 8 inches in my Z direction. Let's see what happens. And yep, wrong one. Let's go back. I just want one. Right, we all trial and error this. We all know the cleared 2, 3, 4, 5, 6, 7, 8. At what was that? 50 inches, 60 inches. Doesn't matter for the example. 60. Okay, so I'm going to create 7 of those linear sketch patterns. I don't need those planes. They're actually not doing me any good right now. Fully define them. We'll skip that part. I always fully define. Shout out to Toby. And we're just going to extrude these out blindly through the wing. We'll do a mid plane to make sure we're covering everything.
Yeah.
And maybe we'll extend that a little more. We'll do a time check too. 15 minutes. Perfect. Okay. Did I? Don't merge these.
Don't merge these. Yeah.
Yep. So then we can do a Boolean operation. So we now can divvy this up and create a bunch of bodies through Boolean operations. And how many we're going to do? 1, 2, 3, 4, 5, 6. So we create 7 of those extrude thin. Those extrudes. I'm going to thicken these up a little bit. They're 0.1 inch. We wanted them 4 inches. And we'll do that mid plane. Okay, so but to do that, when you do a Boolean operation, it deletes the bodies, right? There's some control that you don't have. So I actually need to create the wing, and we're just going to do a copy.
A copy. Yeah. Yeah.
Yep. So move copy our bodies command. Just create a copy. Let's grab this wing. Number of copies.
Yeah.
We'll do 7 because we want to have 7 intersections. Give you this saying, hey, you're not moving it anywhere. I don't want to, so that's fine. And then we'll go through, and this is just doing your combine. And I love Boolean operations.
Yeah.
Not only because they're cool, but just saying that you're doing a Boolean operation makes you sound like you're doing something pretty wild. And we can do a common. So we're just going to click on the first body, and we're going to grab this, click the OK. Okay, we're going to repeat the command. And I've just added it here. For some reason, the return key won't do it, so that's fine. We just speedline this. And you'll start to see inside of here that those are being built, right?
Yeah. Yeah.
And every time I'm just subtracting one of those copied bodies out because it's just leaving the overlap of the geometry. And we should have a total of 8. We got our wing, hide that out, and there we go.
Yeah.
Okay, one last thing I want to show on here. Because again, this is all based on an equation driven from the people who are really good at making wings. Brought that into SolidWorks, and then I can start to build this out. Now, here's kind of the last, I would say. You could do it as a solid or a surface body right away, but either way, we have to manufacture this thing. There's things that are involved. Sheet metal is going to go on top, or a lot of times smaller planes. This is composites. So using a surface, you could still do it later on that initial extrude. Surface loft is a nice way to do it. Here, I'm just going to do an offset surface, and we'll grab that wing dimension, and we'll say it 0. When I say 0, it turns into a copy surface.
Copy surface, yeah.
Yep. And now I've got a surface body that represents our wing. And here's the only thing I'm going to point out is does require complete flattened surface. Is that SolidWorks Professional or Premium now?
I believe it's professional.
Professional.
Still need to, cross check. Yeah.
All right, so let's hide this guy. So now I have a wing that's starting to come to shape, right? We have the wrap outer wing. We'd still go back and have to do some detailing in terms of the flaps, the ailerons, and whatnot that go on the outside. That's why I cut the back off, because I would redo this for the tail end section. You still have the spar to add to it. Obviously, we have to do some lofting if we're going to have whatever the end or capping looks like for the wing. But what's really slick is at this point, since we have really good curve geometry coming in because it's an equation-based curve, healthy geometry coming in, we've got a surface body that's generated essentially with that, is we can come back through and use this surface flatten tool. And I'm going to say, grab this and let's do it relative to this bottom edge. And that'll mesh this for me. And we can cut it out. And now I have an exact pattern of what it would require to actually wrap this. So if you're using, a full sheet, like if this is an RC plane, I guess, we'd have that. Otherwise, in a real plane, it's either sheet metal, as we all know, going through and having this kind of bounding box size or raw geometry size of wraps the wings. But we can extract that out from there as well.
Yeah. Mike, I just want to clarify. So surface flattening is still part of premium.
So part of premium to do that.
Yeah.
Got it.
Yeah.
It doesn't account for material stretch, right? So if it is sheet metal, we were doing it in one big piece. There's obviously some physics that occur when it's being formed. But composites, this is a great example. And I keep thinking RC planes, or if you wanted to 3D print a lot of the ribs and then come back and wrap it with a composite of some sort, you're going to be able to get the exact pattern based on this shape. And you can right click here, look at things like deformation plot and so on to see, where you might have extra stretch that occurs. This is pretty minimal. We're getting 2%. So it's a cool feature, but again, requires a little bit higher level license. All right, we're running low on time. I'm going to keep moving. Any questions coming through? People enjoying this? I don't know.
Yeah, I believe people are really enjoying this. So there's a question from Deepak. Can't we use one body and one feature to get these combined common bodies?
Because what happens when you use that Boolean subtraction, it takes away your your master wing body that just disappears and leaves you. So I don't think so, but Deepak, I mean, yeah, if you think of something, just let me know on LinkedIn. I know we're connected there, or shoot me an email. That's just the way I've always done. When you do, like, I did a paddleboard design, and figuring out those ribs, it's always been just the copy body approach, and then subtracting those extra bodies away as you go through the features. You could probably connect them if you did this. If you connected all the ribs together so they're one solid body, then you could do it in one go. That makes sense.
Yes.
No,
so Deepak is saying maybe using intersect, maybe. So maybe we can.
Oh yeah. We can try that. Yeah, that's a good one. Intersect tool. It's another one of my favorite enhancements over the last 10 years. Okay, let's talk a little bit more. So that was using.
Like you can continue with your example, but I would like audience to share in chat what are the key takeaways they have learned from your last, you can say, example. I have tons of takeaway, but we are getting short of time, so I'll restrict myself. Over to you, Mike.
Thanks, man. The API to add service flag. I don't think so. I don't know though. I'm not an API guy, but you might want to call reseller on that one. Yeah. All right. So let's go in. My next example was getting into some fun equations. This one's pretty quick. I can make it quick, but another way you can drive your sketches is by using basic equations as a parametric true equation versus imported data points. So the wing was an imported set of data points. SolidWorks did the job of connecting those with a nice spline, and we leveraged that. Here, what we're going to do is actually come in, and on my front plane, I'm going to give this a equation, and we're going to do an equation-driven curve. When you see this when you're on a 2D sketch, you're going to have a 2D explicit or parametric option. This is going to be like y equals and so on. So a really common one for this is going to be a horn. And let me find my little cheat sheet here that I closed out for some reason. So like a brass horn, or think of just a concert horn. You have Gabriel's horn, which is simply just y equals 1 over x, right? So inputting this value to it, you could try to sketch it out. You could probably go get a picture of a horn, but to get an actual precise value for horn, just using these equation sketches, and we'll do that. Oh, not 0. Can't divide by 0. I've done that. The messages here are pretty good. It'll tell you if you're on spot or not, and then click the OK. Let's go ahead and fit this. And this is actually the shape of a horn, depending on the style of horn. So if you're lower note, higher note, trumpets, and so on, that's gonna dictate how much of a shape that goes through. But that's just a simple equation of 1 over x. And that's actually a true sketch too, not an equation. We don't have to do any manipulation to it. It's ready to go. So things like coming back and doing my surface revolve and generating that out, I'll see we have this perfectly shaped horn. Now, you can get a lot more fun with these. And if you're wondering to explore a little bit more, great way to have fun is have a conversation with your favorite AI large language model about cool equations. That's what I was doing this morning, and I actually highly enjoyed it. There's another website as well called, and I want to give a shout out to it, is Desmos, DESMOS.com, which is an online graphing calculator. This is going to have equations. You can play around with things. It's a fully integrated, interactive way to plot out equations to be able to play with and then get recommendations. And if you search for like cool 3D equations, that comes up and you can look at them and manipulate them. So way you can begin 2D equations, simple enough. Create a sketch on a 2D plane and then go ahead and input your equation and you're going to get your value. If you need to go back, when I double click on that sketch or edit this way, that will go back into the equation itself, and we can set those parameters to be different, right? Oh, that's the length. We don't want that. We want to make, whatever, 1 over x squared maybe, and play around with them, see what happens. And at 10, and you're going to get a sharper horn there.
Yeah.
Okay, so that's cool, but where it really gets fun is being able to do 3D driven parametric equations. And this isn't as intuitive to find. So what I wanted to show is how we can create some fun spring shapes, more kind of artsy style, I guess. I don't know, the engineering application, I'm sure if you think about it, that could be out there. So here's a trick. If you want to create a 3D, you need to come in and create a 3D sketch. You can't start on a plane. So that's it. That's the secret sauce. Then when we come in and we start building our equations, equation-driven curve, you're going to notice that we now get X, Y, and Z for our parameters. We can start to put things in here. And now I could really bore all you and manually type in these, but I cheated and went ahead. So like a simple growing helix, you've got your constants. Where did that sheet go? 2D curve constants, which is just going to be this 5, the 0.5 t. Those are what we can play with. This 0.5 t here as well. I'm just going to copy that. Well, let's just use my notebook there, and we'll say from 0 to whatever 50. Okay. And just like that, we're getting a helix driven curve. And playing around with these constants, you can start to see what those might change. Or if you're really good at math, you can just look at it and visualize it in your head. I'm not that good at math anymore. I don't think I ever was, and you start to get some stuff that would be nearly impossible, in my opinion, to be able to create a 3D sketch with a spline that is perfectly shaped. So really cool way to do this.
Way to create curve. Yeah.
Yeah. And you don't necessarily need to, if you have data points of something you're trying to do, you can use that, put it in things like Excel or like MATLAB or some of the higher end ones to generate out a curve, an equation for those curves, and bring it in here and get that exact curve that you can start to finesse a little bit. Because then from here you have a 3D curve, so we can do a swept boss and do something like the circular profile. Oh yeah, I forgot to mention, if you are doing this, circular profile has a default value. Clear out the path before you switch to circular profile, because it'll speed up the process. We'll give that a 2 millimeter, and then just like that, we have a pretty wild looking shape in CAD that would be a little more difficult. And you have fun with it, because there's a ton of examples out there to build these and do things like sweeps. You can do things like revolves on 2D like sine curves, cosine curves, and so on. Okay, so I've got 2 minutes left. Oof, we're gonna go long. I apologize. So the last thing I wanted to show you was back on configurations, and I've been working on my deck, so I have a ton of 2x2 that was for the dowels scrap that's laying around. And I've been trying to figure out what to do with it, and I was going to make some little tables to put outside. So nothing new here. I'm using weldments, multi-body approach, weldments. Got my softwood 2x2s. Let's just take a look. We're going to have some dimensions. I don't even have any global variables or anything like that going on here. Inside, there's a pattern. This is the only thing that SOLIDWORKS is doing, is where I'm just saying, hey, do an up to reference. So patterning 1 2x2 and just saying go to this face. And no matter what, space them at 2 inches. And it's going to, because I'll do 2-inch increments, we'll get nice spacing. So I'll show you what that looks like. Maybe this better explain it. Oh, my mouse hit my coffee mug. So if we pull this out, then we'll do it. Oh, stop that. Oh, that's right. I've got this is driven to a table. So let's keep moving since we're low on time. But you're going to see that updates. And as soon as we get to the next incremental 2 inches, we'll get the exact spacing we want. But what I wanted to do is have this be an intelligent design where I could just put in my values. So what I've got here is I have a default table. I've got, that's it, one configuration. I killed out the as welded and the as machined configurations for weldments. I just want the default. Keep the default name, that's key. Insert a table. And if you go through and it was talked about earlier with naming your values, like giving that D1 at Sketch 1 a name, this becomes really handy when you come in and insert an Excel design table. because it'll extract out those values and it makes it a lot easier to work in. This Excel design table, which I've already created, so let's edit the table. We'll take a look at it. What you're going to see here is that this has been built with a configuration, just asking me if we want to add anything, and this hopefully doesn't get blown off my screen. Yeah, I've had weird scaling issues. Sorry. And we'll see that we have leg height, nicely named variable down here. Let's do that. Leg height, leg table length, table width. Again, I just renamed those dimensions to something I can remember. And then we have suppressed or unsuppressed for the trim that's going on here. That's just going to be this like 2x2 lower portion and then this little apron. So I've got the Excel table, which was driven by SOLIDWORKS. They did that. And I've got this default. Now, here's what I think is a really unknown little powerful tool is this property manager. You can get to this by right-clicking on the top level, and you're going to see build. Let's just do it. Oh, you know what? I got a better idea. We have a incomplete one. This is where I wanted to start. So you can see where it lives, because once you build it, you can't recreate it. Okay, so here, no design table, and you're going to see this configuration publisher. This is really cool. I'm going to select on that. It's going to tell me I need a design table. So auto create using Excel. Tells me, what do we want in here? Okay, I want my table width, my table length. We want the leg height. We want, these are all profiles. I don't really care about that stuff. Cool, that looks good. We'll click the OK. And it builds all of that for you, so you don't have to go and do that extra work. And then what we can do is start to build in values here, or just leave it. We have one configuration still named default. Okay, let's go back to that finished one, and I'll show you where this gets. And again, there's information online, other YouTube videos you can follow along. Oops, that's not what I want. Control tab. Come on. Why isn't that working?
Mike, I have been a great fan of this configuration publisher when I used to go and demo this product to the customer. So I've, during those old days, I've created so much of you can say customized demo content using publisher, and people always used to get zapped to see the potential of this tool.
Yeah, it's great. It's such a cool little hidden gem because again, it's leveraging this Excel table, which it does a great job creating on its own. And then I know what's going on. It's hiding the table somewhere. There it is. No, that's something else. Where'd you go, table? Configuration publisher. Oh man,
just check your screen.
Yeah. See, the problem is I have between this office and my actual office, I have different screen setups, and it's there. Just don't know where it went. Okay, I'll explain it. So you get a little screen and you just drop and drag and you set tables and drop downs. That's it. Super easy to use. You can predefine the variables you want to be able to fill out. So what happens, oh great, now it's going to be, I got to kill it. Don't let me go away. There, all right. Let's just try it one more time. Okay, let's update it. That's scaled right. Did you give it to me? No, not yet. Oh, the suspense. Dude, that was property manager. All right. Well, yeah, that's what I wanted. And now it's there. It's somewhere.
Yeah.
All right, go away. That's fine. Okay, so let's go ahead and what's the magic, right? Why is this so cool? So now when we go through and if we make an assembly and we want to import this, our completed table, once we drop this in here on the left-hand side, you're going to see what I would have created. What I couldn't show you because of scaled off into the abyss. We have our length. I just preset these values, 10, 12, 14, again, 2-inch increments, so my pattern works nicely. The 22 width height's going to be, I don't know, 10 inches. And we'll say, let's just do the bottom cross support. So none of this has been created. I only had the one configuration in this model. And what the configuration publisher does in the back end, it comes in here, it's going to create a new line, add in those values that we just input. and then it's going to create that model for me right inside of CAD. And now I've got the original model will have that configuration existing, and I have an assembly with it built inside of it. And there you go. That's my table.
Pretty cool, Mike.
Yeah, I love it. That's it's
Yeah.
like when I was like, how I had forgotten about it. It was such a great enhancement. So
Exactly. Yeah.
all right, sorry we went a little long. Man, I hope you guys got something out of it. At least I know you're all going to go make airplanes this weekend, and that makes me feel
Yeah,
nervous.
definitely. So, Mike, thank you so much for walking us through these powerful tools today. So, I know our SolidWorks community really appreciates your insights and the practical tips that you have shared. I have learned a lot, or probably re-remembered a lot of things that I used to do earlier. But yes, it was a great, knowledgeable session today. So, to everyone watching, remember the features we have explored today, from configurations to equations to global variables to configuration publisher, are going to make your design process more efficient, adaptive, and much more fun. So if you found this session helpful, be sure to check our future deep dive design sessions, and keep experimenting with these tools in your own, can say, project and day-to-day work. So we have this new website that we believe can, you can take a look. It is dedicated to 30 years of SolidWorks. So, well, you can just go ahead and just explore the past 30 years of SolidWorks, the from 1995 till 2026. What all we have done to the software. So it's a cool little website to follow. And then definitely mark your calendars for what's new in SolidWorks 2026 event, which is scheduled for October 16th, 11 a.m. Eastern Time. So we would love to see you in this event. And once again, thanks again for joining us today. So until next time, so keep designing smarter with SolidWorks.